Redundancy, building resilience into the network. First is the redundant links. Implement multiple network links between critical devices, ensuring that data can flow even if one link fails. This approach provides failover capability, minimizing service disruption. And there are some examples of redundant links. First is the website links. A link that connects to another link that goes to the same page. This can happen when websites uses images that are also hyperlinks or when HTML tables are used for layout. Next is network links, a link that prepared in case another link fails. Like example, in stacking switches, redundant links are prepared in case the main link breaks down. Third is the multi-path and redundant links, a link that prepared in case another link fails. For example, Third is multi-path and redundant links. When there are two multi-paths, there are two redundant links to the same LAN for each in the two fiber cards. And the second is redundant power supplies. Ensure that critical networks devices have redundant power supplies. This prevents service outages due to power failure, ensuring uninterrupted network operations. And there are some examples of redundant power supplies. First is the Cisco networking equipment. Uses dual redundant power supplies which are modular and allow users to replace faulty power supplies. And the second is the Aton PTI offers three types of redundant power solution. Bravo, and the third is the Bravo Electro offers the UHP 200R, UHP and 350R, and UHP 500R series, which are compact and have an automatic failover mechanism. The redundant power supply are used in situations where uptime is critical, such as in equipment and hospitals. They are designed to minimize the risk of a complete computer shutdown or failure by providing an extra power supply that can take over if one fails. So that is the redundant power supplies. And the third is the redundant routers and switches. Deploy redundant routers and switches, providing backup pathways for data traffic. This ensures will interrupted network connectivity even in the case of device failures. There are some examples of redundant routers and switches. First is the duplicate systems. Create two identical systems in K network locations, such as using two identical core switches. Second is the stackable switches. Uses stackable switches to create a redundancy by connecting them with a stacking cable. The diverse trunking. Use multiple physical connections or trunks between router switches or between a network and service provider. And the fourth is the redundant switches. Use backup switches that automatically take over the functionality of a main switches if they fail. And the fifth is the link aggregation. Combine multiple network connection to act as one, which increases speed and reliability. Reliability, ensuring consistent network performance. First is the network monitoring. Implement robust networking monitoring tools to track network performance, identify potential issues early, and proactively address problems before they impact users. The second is the network security. Implement comprehensive security measures to protect the network from cyber threats. This includes firewalls, intrusion detection system, and robust password policies. So the network security is the firewalls, intelligent electronic system. The third is network maintenance. Regular maintain network infrastructures to ensure optimal performance and prevent issues. This includes software updates, hardware upgrades, and route and checks. So they are the that maintain the network. And the last is disaster recovery. Develop a disaster recovery plan that outlines procedures for restoring network service in the event of major outage. This plan should include backups, failover mechanism, and communication strategies. Network design considerations. Factor: network topology. The description is choose an appropriate network topology. The best suits that the organization's needs. Common topologies include star, bus, ring, and mesh. Physical infrastructure. Consider the physical layout of the network, including cable routing, device placement, and environmental factors. Network segmentation. Segment the network into logic units to enhance security, performance, and manageability. This can include separating users and traffic from critical servers. So, physical infrastructure is the device placement and web factors. And the network segmentation. Quality of service. Implement quality of service mechanism to prioritize specific types of traffic, ensuring that critical application receive the necessary bandwidth and resources. The network segmentation. Network topology is a visual presentation of a network structure, including the devices, their connection, and their physical or logical relationship. Some network topologies. Star topology is the devices are connected to a central hub or switch, and messages are passed through the hub to the destination. If the central hub is working, the rest of the network is unaffected if a single node fails. The ring topology is devices are connected in a circular data channel with each device linked to the others. Packets are passed from computer to computer in a ring, and each computer checks if the packet is intended for it. Bus topology. All devices are connected to a single cable with a bus, which serves as a shared communication medium. Mesh topology. Each device is connected to every other device in the network, forming a mesh-like structure. This topology is often used in large organizations because it can handle a large amount of data traffic. Physical infrastructure refers to the physical structures and systems that are required for a social to function and survive. Includes the transportation networks, power grids, water treatment facilities, communication networks, sewage and waste disposal system, housing, manufacturing facilities, commercial buildings, and the last is retail. And that's all.